In every laboratory project, we focus on a specific topic or a technique to draw 3D shapes using OpenGL library. However, it is important to also keep an eye on the big picture, covering both CPU-side application classes as well as OpenGL API protocols that we must follow at different stages of 3D rendering at runtime. In this video, I would like to share with you two handouts right here, describing on one hand our application structure and on the other OpenGL application scaffolding nodes, categorizing parts of OpenGL library into a framework best suitable for our needs while organizing the structure of our program. I am opening both handouts side by side, and here on the left-hand side our application structure is documented using a pseudocode to keep everything as brief as possible. I suggest that you pause the video right now and review the pseudocode legend. If you are not immediately comfortable with its description, don't worry, it will become clear as we discuss the individual pieces. On the right-hand side, I focus primarily on OpenGL API used by our program and trying to explain why we call this or that OpenGL function to satisfy the needs of our application. So here we start with the most basic definitions of terms, which you can also find in our OpenGL online textbook. So when we refer to geometry, model, mesh, or object, it's a single object in 3D space made of triangles. So first, it's loaded or instantiated in CPU memory in form of floating point number arrays, but also other data type arrays. And later, it needs to be uploaded into the GPU memory for rendering or using by our vertex and fragment shaders. The next item is vertex array object. OpenGL structure stores all state needed for drawing an object. And in order for us to be able to access the state, we have to be able to identify individual pieces in OpenGL memory structure. And this is done by both vertex buffer object identifiers and vertex array object identifiers. In other words, these are unique handles that we have to provide when calling OpenGL API functions to request specific services or enable and disable certain functionality. In summary, vertex buffer object is an object that represents an array already loaded into GPU memory. It's an OpenGL structure that provides access to a buffer of memory. So this object is just an integer, unique identifier that we can use when referring to a buffer of memory in GPU. And vertex attributes are input parameters to our vertex shaders. Our application begins its execution in the main function, and the responsibility of main function is to initialize and set up GLUT, which is OpenGL utility library, and glue, OpenGL extension wrangler library. So in the pseudocode, I'm trying to keep this notation as brief as possible. So here in the comment, we say that we initialize GLUT. So we basically choose how to set up some memory buffers for the display, how to set up the window size, how to create the actual window, what callback functions we would like to connect to receive notifications from the system. And then we get to the next stage, which is glue init. It's just one single call that initializes OpenGL driver and assigns actual address to every function in OpenGL API. The next step is to compile the shader code. So we have to load the shader code from a text file and submit it to OpenGL driver to compile, then quickly check the results of that. And if we use multiple shaders, we obviously have to do this for each pair of shaders, for each pair of vertex and fragment shaders. Then we configure the light parameters. So here some of these comments actually overlap between both of these handouts, and that's the idea. Here I try to expand a little bit more on the actual calls, and here I'm trying to keep it as compressed as possible to give you the highest view of what is happening at a particular stage of our program execution. Another responsibility of the main function in our program is to set up each model, each object that we'd like to make visible in 3D space. So of course we use C++ model class to help us manage the properties of individual objects in space with geometry, colors, textures, normal vectors, and all sorts of other attributes we need to keep together in a single object. So we have a constructor that executes first for the model object. Then we typically upload bitmap texture if we'd like to use a texture with our model. And in our current design of the model class, the model has a pointer to a texture object in computer memory. Basically, one texture per one model for us to just get started with the textures. The textures will be covered in the videos coming up next week. Once the model object is ready in CPU memory, we call its function upload to server. So this function is responsible for sending all information about our model to GPU, right? So this is where GPU gets loaded with all of our geometry and other vertex attributes that we'll be using with our model. Next part of the main function is to construct the camera object. So we also have a separate class to hold the properties of the camera. For example, we would like to know orientation of the camera in the world space, its position, and this is also a nice place to hold the view transformation matrix and the perspective matrix. So once all of our objects are all set to go, we enter the main loop, which is going to tell OpenGL library that we're ready to render our first display frame.